Okay, gentlemen, here we are. We're back into the Cold War. This is the slide we left off at. Can anybody tell me what's due in this class the day after tomorrow? Oh, yeah, that thing. Yeah, essay. You got to bring in your essay. No, it's the day after tomorrow. It's no. That was a previous one. I announced it yesterday. Let me rephrase that. I reminded people yesterday that it's Thursday, October 5th. Today's the 3rd, so it's not tomorrow. But and what time of the day is it due? It's due at 2:20. All right, so last time we were on this slide. So now we're going to start. So now this is effectively Chapter 8, Cold War Part 2. So this is Chapter 8, Cold War Part 2, if you want to write that somewhere. Well, we're just going to take one quiz for the whole chapter, so maybe it doesn't matter that much. So here's what I want you to get out of this slide before you go and write it all down. I mean, which is totally awesome if you just love memorizing facts. Don't get me wrong. I think this is really cool stuff. But in 1938, so that was a year before Poland was invaded. So one could argue before the beginning of hostilities, military takeover. A Caproni, that's an Italian brand of airplane manufacturer, climbed to 56,850 feet. To this day, that is still the world record for a piston-powered airplane, 56,850 feet. Holy Moses. Can anybody think of a reason why do we not have higher altitudes in the last 60-some, almost 70 years? Because we've moved on from piston-powered engines to jets. That's one fantastic reason. Can anybody think of another one that I'm thinking? Huh? Died? Oh, no. He didn't die. The gentleman that was flying this? Okay. And you don't have to write this part. But no, there's only so much you can do to a piston engine to make it keep producing power. You put a turbocharger or a supercharger on it. Cars, they call them blowers. They also have turbochargers. But even if you keep putting on more superchargers and more turbochargers, those things take power off of the engine. So at some point, they don't do any good anymore. You notice in 1948, somebody broke the altitude record for airplanes a couple of years after, 3 years after the war was over. The de Havilland Vampire is a first-generation jet airplane. It was the second jet airplane they made in England. The Gloucester Meteor was the first one. You don't have to write that down. And then the second mass-produced jet airplane in Great Britain was the de Havilland Vampire, and they made a lot of them. And look, it was only 3,000 feet higher. The English Electric Canberra, look, it only went up by 6,000 feet more. And, of course, one of my personal favorites is, look here in 1959. The Lockheed F-104 Starfighter. The Lockheed F-104 Starfighter, you don't have to write this down, but the Lockheed F-104 Starfighter was the first airplane that was mass-produced, in a factory, not just one prototype, not just one test airplane, but the Lockheed 104 Starfighter was a mass-produced jet fighter, and it was the first mass-produced airplane that could go Mach 2 straight and level. And so that was a pretty big jump. But look, 2 years later, MiG-21. So here's what I want you to get out of this slide, is number one, what Jacques Cardoso said, is that by the end of the war, let's don't try to get bigger, faster piston-powered jobs. We got jets. So people stopped worrying about having really high-powered, high-altitude, fast airplanes propelled by piston engines. The second thing you ought to notice is that by 1960, we're flying at altitudes where you have to wear a spacesuit to do it. there's a thing called the Armstrong Line. It's at 64,000 feet approximately, and it's not named after Neil Armstrong. It's named after a physicist long before that. And here's what happens. At sea level, what temperature does your blood, is your blood? 98.6 Fahrenheit. It's also 37 degrees Celsius. Okay. How hot do you have? Would you have to heat you up to get the water in your to boil and try to turn into a vapor? At sea level, 12 degrees Fahrenheit, or, which is also, I know we're in America, we're one of the 2 countries on the planet that still uses Fahrenheit. It's 100 degrees Celsius. But if you go up in higher, and it gets higher and higher and higher, and there's less pressure, it's easier for water to boil. Has anybody ever looked on the back of a brownie or a cake mix and it says high altitude directions? It has you do it a little differently? Well, the last place I lived was at 5,000 feet. I lived in the mountains in northern Arizona. So we always did the high altitude directions. It's because water doesn't boil at 100 degrees Celsius or at 212 degrees Fahrenheit. It's less. It's about 202 degrees Fahrenheit at 5,000 feet because there's less pressure. The higher you go, water boils easier because there's less air pressure on the water. The water molecules can escape as a gas. At some point, the pressure gets so low, the boiling point of water comes down to 98.6 degrees Fahrenheit, and that's the Armstrong Line at 64,000 feet. So if you're in an airplane at 65,000 feet and it depressurizes, the liquid in your body will start trying to turn into vapor, a gas. And the problem with liquid water turning into a vaporous water is that it expands. A gallon of liquid water, if you at sea level pressure, you turn it all into water vapor, it will expand to 1,700 times more. 1,700 gallons. So let's think about the liquid water in your body. You're at 65,000 feet, the airplane depressurizes. Your body starts to turn into a vapor. It expands to 1,700 times bigger than it was. Are you going to be happy? You're not going to be very happy. Was there a question? So, when I was in the U.S. Air Force, there was a regulation that said if you fly above 50,000 feet, you have to wear a pressure suit. So if the airplane 55,000 feet. So that's what I get out of this, is that we're now flying jets high enough that you got to wear a spacesuit. So I'm telling you, even they probably didn't in 1938. Well, actually, they might have. But 1948 and on, I bet you they were all wearing a spacesuit. I mean, today we'd call them spacesuits. Back then, they probably called them pressure suits. And you'll notice Italy, Great Britain, U.S., Soviet Union. Wow, U.S., Great Britain, Soviet Union. Who was on the good side during World War II? U.S., Soviet Union, Great Britain. France was kind of out of the picture because their aircraft manufacturing got run over by the Germans because Germany invaded and took over all of France, so they weren't making much at that time. And so here's the Caproni that went to, look at the blade pitch. Look how high pitch. That's like high gear. That's like 20th gear in a car. You're going to go to the Bonneville Salt Flats and you want to go 300 miles an hour. You only got one gear. You're going to put it in gear 100. You probably have to give it a push start. A biplane holds the record for the highest piston-powered airplane ever. So here's the Gloucester Vampire. I'm sorry, it's the de Havilland Vampire. One jet engine in the middle, 2 tail booms going to the back. They actually made an aircraft carrier version of this. Can't remember what they called it. Here's the British Electric Canberra. The U.S. actually, a company in the United States actually got a license to build these in the U.S., and they actually made a version with extra long wings, and it would go and cruise around at 60 or 70,000 feet like a U-2 spy plane. And in fact, NASA still has 2 of these painted white with blue trim, and they use it for high-altitude atmospheric research. So that's probably the only 2 in the world that are still flying. And then here's one of my personal favorites, the F-104. It's got, looks like 4 fuel tanks on it. You can't see the one on the other side. When I got one, I did a co-op and internship. I stopped going to school for 6 months, and I went to what's called Edwards Air Force Base. It's in the Mojave Desert of California. And it used to be called, NASA has a center on the Air Force Base. It used to be called Dragon Flight Research Center. But after Neil Armstrong died, they renamed it to Neil A. Armstrong Flight Research Center. I went down there for 6 months, and I learned how to be an airplane mechanic on F-104s. So my first 6 months of paid work as an airplane mechanic were taking these apart, inspecting them, fixing them, and putting them back together again. My roommate at the time, who was also from Reilly College, his name was Bob Garcia. After we both got out of A&P mechanic school, he got a job there at NASA. He's now the director of maintenance. He sat in A&P school right there on that same linoleum you're sitting on. And there's that MiG. I don't know that symbol on the tail. I don't know what country that is. Okay, let's look about some speed records. So, I personally like the Belle X2 because it was the first flying machine to ever go the speed of sound. 1947, Chattanooga, October. I can't remember what day in October. Bullets had gone supersonic before this time. That lead round thing coming out of the end of a really high-powered rifle, or I guess cannons or howitzers or whatever. I've not researched that. But there were projectiles being propelled with gunpowder that had already gone supersonic. But there were still people that thought you can't go supersonic with something with wings on it. And there it is. It was propelled by a rocket, not a jet engine. And I like the North American F-100 because it's the first mass-produced airplane. It was a fighter jet. It would go straight up level. It would go Mach 1. Because you're cheating if you have to push the nose down and let gravity help you. That doesn't count in my book. And who's writing the test? Oh, wait, that's me. So my book's the one that counts, right? So here's a picture of a North American F-100. Super Sabre, yeah. Had afterburners. The first airplane to go Mach 2 was the Douglas D-558. I'll tell you what. Why don't you stop writing here for a minute? Because I know you'd rather memorize this entire page and regurgitate it on the final exam. So you don't have to stop writing if you don't want to. But how about if we wait till the end and I'll tell you what's the test question going to be? Does anybody have any problem with that? Because if you stand up and tell me you don't like it, I will not tell you the test questions at the end of this slide. Oh, okay. Sit back down, Josh. I'm just kidding. The D-558, this was a test airplane. How come it's not staying there? Well, it's because it's going Mach 2. That's why you can't see it. Here. No. And I already told you that the F-104 was the first mass-produced airplane that would go Mach 2. And one could argue, well, which is more important, the first airplane that went Mach 1 or the first airplane that went Mach 2? Or the first mass-produced airplane? I think it's the first mass-produced airplane. I think the F-100 Super Sabre is more important than the first airplane that went Mach 1 because this one, we built hundreds, if not thousands of them, and it could go supersonic every day. Same thing with the F-104. The United States, Lockheed is the manufacturer that made it. Lockheed sold this airplane to at least a dozen countries. And I think including Germany and Canada. And I think Germany was one of the last countries to have them. The problem is this thing would. How would you like to fly an airplane that stalls at 230 knots with the flaps up? And it only stalls at 190 knots when you have the flaps down. There was 2 nicknames for the F-104. They called it the missile with a man on it because it would go so fast. And, of course, it looks a lot like a missile. And they also called this the Widowmaker. Yeah, because people were used to flying around on final approach to land at 150 knots, and this thing would stall out of the flaps down at 190. Don't quote me on those numbers. Oh, you need like 7,000 or 8,000 feet. Yeah, and you'd replace the brakes a lot. The reason I showed you this picture, you notice it's white with blue trim, and it says NASA on the back. My fingerprints are inside of that airplane. because I worked on it in 1979 when I was doing my co-op at what used to be Dryden Flight Research Center and is now Neil A. Armstrong Flight Research Center. You'd actually buy a model airplane with this paint job on it. I need to buy one and build it and then stick it in my office. And then I'd have a really pointy nose on that airplane, and I could poke somebody's eye out in case I needed to. The first airplane that would go Mach 3 was the Belle X2. Let's see how, there it is. This was another rocket airplane. So these first three airplanes, well, I'll get to that here. So there's the X2. And then the A-12. This is the predecessor to the SR-71. You notice the difference between an A-12 and an SR-71. An A-12 only has one pilot, and it was funded by the CIA, not the U.S. Air Force. And it was designed as a spy plane to literally fly over enemy countries illegally in violation of ICAO rules. The SR-71, they put a navigator in the back seat, as well as the pilot in the front seat, and they took pictures out sideways, so they'd fly about 100 miles away, but they'd be up at 80,000 feet, so they could take pictures into that country for 500 or 1,000 miles. So it was legal to do that. Of course, there is, what's rather interesting is, they retired these airplanes, a decade or so ago, except for a couple of them that NASA had. What did they replace them with? The U.S. military is telling no one. They won't even tell you that there was a replacement. You think if this thing would go Mach 3, I mean, it cruised at Mach 3, not just could go Mach 3 if you turn the afterburners on. This thing got up to 80,000 feet and it just sat there at Mach 3. Here's how fast that is. You've taken off and you fly due west towards Hawaii and you're over L.A. You're flying towards Hawaii and you're over L.A. and you shove the stick over to make a right turn and you make a big giant right-hand turn and you roll out, you're over San Francisco. I'm not making that up. You're going 2,000 miles an hour. Well, think of the centrifugal force if you try to go into a turn at 2,000 miles an hour. Think of the centrifugal force on a merry-go-round, and the outside of the merry-go-round is going 2,000 miles an hour. Do you think it's going to fling you out sideways a bit? Right. So you can, these gentlemen in here, back then the U.S. military didn't let women fly combat missions. So they were all men that flew SR-71s. So I don't know. I've never looked at it. But let's just say they pull it into a 60-degree bank and it's a 2G turn. How long does it take? It's quite a bit of push to get to get turned, even though you're going 2,000 miles an hour. So, what do you need to know on the test? This is what I think you need to know. The very first airplane that broke Mach 1, Mach 2, and Mach 3 were all powered by rocket engines. I'm not going to ask you which ones they were, but the first airplane ever to break the speed of sound, Mach 1, that's what Mach is. Mach 1 equals the speed of sound. And that's about 700 miles an hour at sea level. It's a little over 700 miles an hour at sea level. So the first airplane to go Mach 1, the first airplane to go Mach 2, first airplane to go Mach 3, they all were powered by rocket engines. And then I think the other thing that's rather interesting you'll notice is that all three of the mass-produced airplanes, first airplane that was mass-produced, that went into production and had a factory and built hundreds, if not thousands, they were all built in the United States of America. And I'm not saying that because I think the United States is the best country on the planet. Not that I don't think America is the best country on the planet. But I want you to think about how much money was the Department of Defense giving airplane designing companies and airplane manufacturing companies. We want bigger, faster, more awesome machines so we can do better in the Cold War and make sure that the Soviet Union doesn't have anything better than us. Because Germany became the good guys. We only sold F-104s. If you want to sell military weapons and you're a U.S. manufacturer, you have to get the federal government to tell you it's okay. So Lockheed only made F-104s and sold them outside the country to countries that the U.S. government was okay, and that was effectively allies of the United States, like NATO, the North Atlantic Treaty. So Canada was part of NATO. Germany was part of NATO. The side of Germany that wasn't controlled by the Soviet Union. Because the Soviet Union, at the end of World War II, they got about half of Germany, the United States, and Great Britain. And France got about half of Germany. And it stayed until the early 1990s. Does anybody remember 1991? Oh, that was the end of the Cold War. You do? Oh, previous life? I have a good story. When we get to the very end of the Cold War, I have an interesting story. So those are the two things I get out of this. That all three of the mass-produced airplanes, the first airplane that was mass-produced that would go Mach 1, first airplane that was mass-produced that would go Mach 2, first airplane that was mass-produced that would go 3, were all built in the United States. And that tells me that the United States was spending an incredibly large amount of money on newer, faster, bigger, better airplanes. Not that the Soviet Union wasn't doing it, but they lost 20 million people in the war. They were still putting their country back together again. Did we have to put the United States back together? Well, we had to rebuild Pearl Harbor. One little island in the Aleutian Islands of Alaska, we didn't really have to rebuild our country. Nothing got, almost nothing got bombed. So, let's take a look at this list. Holy Moses. So, let's see. We got a list from World War I, the things that got better in aviation in World War I. We got a list of things that got better in aviation because of World War II. And yes, here's a whole third set of years across the planet where aviation got better because of wanting to be able to kill people who are bad guys. And girls. Guys and gals. We'll kill the bad gals too, right? I don't know, I never asked that question. I just made an assumption when the nuclear bombs I dropped blew up, everyone there would die. And that the gamma radiation from those nuclear weapons would travel at the speed of light, and since there were no lead shielding in a B-52, I would be radiated by gamma rays, and I would be puking by the time I landed. But that didn't matter because my wife and my kids were back at the base I just took off from, and 2 or 3 intercontinental ballistic missiles had hit it, vaporized my wife and my children into radioactive... Huh? I'm talking about being a member of the United States military on nuclear alert during the Cold War between the United States and the United Soviet Socialist Republic. Wow. So man, we didn't just have jet engines, we made them bigger and better. We had jet engines that would propel an airplane at Mach 3, steady at Mach 3, not just for 5 minutes. And we're not there, nobody's even telling us what we did after the SR-71. I bet you I wouldn't be surprised if we have an airplane that has jet engines and it'll go Mach 5 or 6 or 7, steady, at cruise. U.S. military just isn't telling us about it. So we came up with air-to-air missiles. I think of all these things, I think that's the most interesting one. You can actually launch a missile, and it's got its own radar, and it gets a radar reflection. The radar waves hit that enemy aircraft. It bounces back to the missile, the head of the missile, and it can tell where that airplane is, and it steers itself to shoot down that other airplane. They also had to do the same thing with infrared, so it'll see the heat off the engines. So this would be a good 1, 2, 3, 4, 5, 6. Name 7 of the 6 different things that were dramatically improved during the Cold War in aviation. So we'll probably have one list on World War I and one list on World War II. And I'll tell you what, I'm going to make you a deal. On these 3 lists, what got better in World War I, what got better in World War II, and what got better in the Cold War, I'm going to say name 3 on each. Not one of each, 3 of each. Is that all right? All right, so I have 60 seconds to tell you a story. So in 1991, the Cold War was over. The reason I know it was over was because I was stationed in Minot, North Dakota, and I was on nuclear alert. That's where you stay close to the airplane, and it's got a lot of nuclear bombs on it and stuff. And if the horn goes, yeah, they're armed. When I say they got nuclear bombs on them. And if the horn goes off, you run to the airplane, you start the engines, you taxi out and take off before the intercontinental ballistic missiles come and blow that base up. And it takes about 90 minutes by intercontinental ballistic missile to get from the United States to the Soviet Union or vice versa. It takes 10, 12, 15, 16 hours by jet. Huh? Well, I think they're satellites, but Armed satellites, it wouldn't surprise me if there were armed satellites, but I think we signed a treaty to not do that. He said grinningly. So literally, I set nuclear alert 1 week out of 3 or 1 week out of 4. And you'd go out and you would pre-flight the aircraft and you would pre-flight the weapons, and then you'd go into the vault and you'd study the mission. There'd be one set of charts in the vault and a duplicate set in the airplane. And I have vivid recollections of opening all the charts and seeing where the bombs were going to drop. And I'd look at where the missiles were going to go, and I'd look up the latitude and longitude of the missile, and I'd look it up on another map, and I'd see where this missile is going to go. Now, I can't officially tell you that there was nuclear alert at Minot, North Dakota, but if you drove by the base on the public road, you'd see these B-52s out there, and there were Chevy Suburbans with 50 caliber machine guns on top with 18-year-old security police there. And underneath the wings were these long gray things that looked exactly like pictures of air-launched cruise missiles. And then there were a bunch of aerial refueling tankers right in there too. Peacetime training, you could put 24 warheads on a B-52. If you maxed it out, you could put 12 air-launched cruise missiles, 6 under each wing. And in the back of the bomb bay was a rotary launcher. And you could put 8 missiles that would rotate and launch another one, rotate and launch. You could put 8 short-range attack missiles. The air-launched cruise missiles would go, and this is all unclassified data, they'd go about 800,000 miles. The short-range attack missiles were powered by, those were powered by jet engines, little jet engines. The rockets, the short-range attack missiles in the bomb bay, they had 2-stage solid rockets. They could go Mach 5, 6, 7, something like that. They'd go 50 or 60, 70 miles. You can even aim them so they launch and turn around and go nuke something behind you. And then you put 4 big old honking bombs in the front. So 4 plus 8 plus 6 plus 6 is 24. And you think about that sort of thing. Well, what's it going to be like when I'm flying over the North Pole nuking the godforsaken commies? Or were they godless communists? I could never figure that out. But you knew for a fact that there was probably 5 or 10 or 20 intercontinental ballistic missiles aimed at Minot Air Force Base. And whoever was there were going to be nuclear dust in about 90 minutes. So I'd have been like an hour into Canada, and my family would have been vaporized. And yes, there was no lead shielding in a B-52. So then you're going to go launch your missiles, drop your bombs, and then I won't talk about the rest of it, but I'll tell you what, next time we meet, I'll tell you about dropping a nuclear weapon at low altitude. Y'all have a good day. Huh? What's that? What's 500 or 5,000? All I know is that aluminum airplane pretty much won't stop any of them. No, I don't know. That's a good question. How many feet of cement do you need to stop a gamma ray? I don't know. Yeah, you